Okay, example 9. Final example before you're going to practice some on your own. This problem is quite complex. Probably the most complex algebra problem we'll have done so far this year. If you read through this, you see that we have gold pellets and copper pellets that are put in water. And eventually we can calculate the final temperature of that mixture. Again, when you have a mixture, remember, we want to set the Q's equal to each other. For instance, sorry, wrong way. Okay, so let's look here then. So we're going to take Q metal equals Q water. Now, we have to decide which side is negative. Is water negative or is the metal side negative? Well, the side that's negative is going to be the side of the substance that has a higher temperature, because it's going to be releasing, hence the negative symbol, heat to the substance of lower temperature. So if I look through here, I see that my metals start out, I have a mixture of metals that start out with 126.9 degrees Celsius. So that's why that side's negative. So, but I don't have one metal, I have two metals. I have gold and I have copper. So I'm going to say negative, parentheses, the specific, not the specific heat, I apologize. Let's try that again. Negative, parentheses, the Q of gold plus the Q of copper equals Q of water. Alright, so that's a lot of values. We got all kinds of things. Remember that for each of these Q's, we've got to do MC and delta T. Okay, so here we have it. And I've typed it up for you, which just makes it fit in there a little nicer. So we have gold is right here. So the mass of gold times the specific heat of gold times the temperature of gold plus, because we're mixing them, so we're adding those on that side, the mass of copper times the specific heat of copper times the change in temperature of copper. We're going to set that equal. Now notice, before I say set that equal, notice I have my parentheses around here and I have negative, because remember the metal is warmer. It's going to release heat to the water bath. So we're adding this mixture into this, making a new mixture of metals and water. So we have mass times specific heat of water times delta T. Now, all these numbers down here are pulled in from up above. Being very careful to pick the right number from the right spot. So 2 grams is the mass, 0.129 joules grams degrees Celsius is the specific heat of gold. And then my TF is just like we've done before. I'm sorry, my delta T is just like we've done before. Delta T is TF minus 126.9 degrees Celsius. Okay, plus 10 grams here, and that's the mass of copper, times its specific heat, which I gave you, 0.200 joules per grams degrees Celsius, times, again, delta T, which in this case is TF, which we don't know, minus 126.9 degrees Celsius. Now remember, notice that Ti is the same for both. That's because we heated both those metals up at the same time to 126.9 degrees Celsius. Now, it appears, I just want to double check my parentheses. Okay, it looks good. Alright, so then we're going to set that to their side. 75 times 4.18, what is for water? We need to know this from our blue card. Times the delta T, which is TF minus 30.50 degrees Celsius. Now, why is TI 30.50 degrees Celsius for water? Well, that's what the water temperature starts out to be. So we have all of this algebra. We have a TF there, a TF here, and a TF there. We've got to get them together. So we're going to do some algebra here. Let me flip to the next slide. I'll walk you through that. Alright, lots to look at here. You might want to pause and copy, and then pause again once you get through the explanation. So, this is the formula from the page before. These are the numbers from the page before. Now, first thing we're going to do algebraically is we are going to multiply mass times specific heat. So this number here, 0.258 joules degrees Celsius, came from 2 grams times 0.129 joules per grams degrees Celsius. And then I just brought this rest of this down. Then I also did the same thing here. I multiplied for copper mass times specific heat. When I do that, I get 2.0 joules per grams degree Celsius. I'm sorry, 2.0 joules per degree Celsius. Why did the grams go away? Well, look what happens. When I multiply here, grams will cancel. Likewise, grams will cancel there. Alright, did the same thing on the other side. I took 75 grams times 4.10 joules grams degree Celsius. I got 314 joules degree Celsius. Again, what did I do? This first step, all I did was multiply these two numbers, bring it down. Multiply these two numbers, bring it down. And multiply those two numbers and bring it down. Alright, now we're going to have to do that nasty D word, the distribution word. So we're going to have to distribute this there and there, and there and there. Okay, so what did I do? Leaving my negative symbol out there, I'm going to leave that out there till the end just because it makes it a lot easier not to deal with a bunch of negatives. So I'm going to take this 0.258, and multiply it by TF. That's how I get that. And I take the 0.258 and multiply 126.9, and I get 34.7. Okay, joules. Notice that degrees Celsius cancels. Think about how that would work. Well, if I multiply this times this, my degrees Celsius for that piece would cancel. Now, same thing here. I'm going to distribute this through. So 2 times TF, so 2.00 joules per degree Celsius TF, and I'm going to also multiply 2 times the 126. I'm distributing that. That's how I get the 254 joules. Similarly, on the other side, I'm going to distribute this, so the 314 joules degrees Celsius times TF, that's how I got that. Then I take 3.14 times the 30.50 degrees Celsius, and that's how I get the 9580 joules. Notice that degrees Celsius would cancel like before. We've talked about that because those units are on top and bottom. Okay, now I'm going to look at the left side and the right side. And let me go down some here on my screen. Looks like I dealt with first this side. So what did I do? Over here, just this part here on the left, I combine like terms. What do I mean? I combine my TF and my TF, so that means that I had to add 2.00 and 0.258. That's how I got this. And then I added my 34.7 and 254, and I got negative because they're both subtracted, so 289 joules. Okay. So then what I did next down here is I just got this negative taken care of. So I just multiplied through, multiplied through. So this becomes negative, and then since this is a negative times negative, this became positive. On the other side, I just carry the other side down from here to here, because there's nothing to do there yet. Alright, now I'm going to combine like terms in this whole thing, because now I can set them equal, because my parentheses went away. So I'm going to combine my TF terms. That's what I did there. So I subtracted 314 from both sides, use my sig fig rules. And then I'm going to combine my non-TFs to the other side. So I subtracted 289 from both sides. That's how I got the negative, because minus 9580 minus, excuse me, let me try that again. Negative 9580, right, because this would be plus and minus 289 joules gives me negative 9,870 joules, 9,870 joules. Now you'll see that the math makes this negative. Now I'm going to divide both sides then to get TF by itself by negative 316. When I divide both sides by negative 316 and negative divided by negative gives me 31.2 degrees Celsius, and that is my final answer. Now, I know that was a lot, and I know I went kind of fast, so you may have to pause and restart and go through pieces again. Now you are ready to begin your homework assignment. You should now be able to complete problems 1 through 15. It is due when you walk in on Friday. Have a fantastic evening. Thank you.